Hello, welcome to this quick, very brief introduction to Kirchhoff's current law and nodal analysis. Now, take a node like that with some resistors, maybe other circuit elements coming off of it, another resistor there, and so this has got a node with three connections. Now, Kirchhoff's current law says that all currents flowing into a node, like these three, must sum to 0. So that's I1, I2 and I3. I1 plus I2 plus I3 must equal 0. And to make this a full circuit, so we can do some analysis on it. Let's call this V1, this R1, R2, R3 and V2. Now, as well as these currents being defined by the way they flow into and out of this node, they can also be defined by the current flowing, the voltages on either side of these resistors, because the Ohm's law says that V equals IR, therefore I equals V over R. So the voltage drop across here, the resistance through it, must cause a current, and that will be the same current there. So I1 also equals, looking at the direction of the current is important here. So if V1 is higher than this voltage here, from here to ground, let's call that Vn, Vn for node. If V1 is higher than Vn, current will flow this way through R1, and this will point inwards, which is what we want. So therefore V1 minus Vn, V1 minus Vn is the voltage across R1 over R1, gives us I1. I2 equals, this one's simpler, there's only one voltage across R3, therefore I2 must equal Vn over R3. However, must be very careful to pay attention to signs. This current is flowing out of R3, but for a positive voltage to be made on R3, the current would have to flow in. So this negative must be accounted for. We can put that there. Failing to account for signs, pluses and minuses, is usually the way people go wrong with these questions. Certainly the way I go wrong. I3 now equals, and we'll be careful about the sign again, so if V2 is higher than Vn, current will flow that way, because current wants to flow downhill, therefore V2 minus Vn over, that's R3, and that's R2. And to solve this circuit, we're assuming that V1, R1, V3, R2, V2 are all given, and we want to know Vn, because from Vn we can find any of these currents, and we know everything about this circuit. So, to find that, we can put all of these into this, substitute them in. Let's do that now then. So V1 minus Vn over R1, and note the minus, that's here, so that's Vn over R3 plus V2 minus Vn over R2 equals 0. And using this, assuming we've got all the values, we can work out Vn, and then from Vn we can put that back into these equations to find out any of the currents. Okay, I hope you enjoyed this, well, hope you learnt something from this quick demonstration of Kirchhoff's current law and nodal analysis. The next one will be about the loop analysis and Kirchhoff's voltage law. Thank you for watching.